Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at Pythagorean triads or Pythagorean triples. So three numbers, A, B, and C, are said to form a Pythagorean triad or Pythagorean triple if A squared plus B squared equals C squared. Basically, if Pythagoras' theorem holds for the three numbers, you have a Pythagorean triple. So most sources require that to be a valid Pythagorean triple, A, B, and C have to be integers or whole numbers. So for example, if we have 12, 18, and 24, this is not a Pythagorean triple. Why is that? Because 12 squared is 144, 18 squared is 324. If you add 12 squared and 18 squared, you get 468, but if you square 24, you get 576. So 12 squared plus 18 squared does not equal 24 squared, and therefore we do not have a Pythagorean triple. On the other hand, 12, 16, 20 does form a Pythagorean triple. They are all integers, but 12 squared, 144, plus 16 squared, 256, does equal 400, which is 20 squared. So 12, 16, 20 is a Pythagorean triple. So the significance of Pythagorean triples is they're going to help us determine what type of triangle something is. So if you have a triangle and its lengths are, say, 12, 16, and 20, you can tell for sure that is a right-angled triangle. So we can update our understanding. A triangle is right-angled if and only if its three sides here form a Pythagorean triad. This is like the converse or the opposite of Pythagoras' theorem. We know that if we have a right-angled triangle, then A squared plus B squared equals C squared, but the converse is also true. If A squared plus B squared equals C squared, then the triangle is right-angled. So what about this triangle here? Well, if we draw a triangle that's 12, 18, 24, this triangle here is definitely not right-angled. So if it's not right-angled, what is it? Well, we can use this rule here. We've already established that if A squared plus B squared equals C squared, then the triangle is right-angled. Turns out if A squared plus B squared is less than C squared, it's obtuse-angled, and A squared plus B squared greater than C squared means it's acute-angled. So here, 12 squared plus 18 squared was 368, which is less than 576. Because A squared plus B squared is less than C squared, this triangle here is obtuse. That means its largest angle, which is always opposite the longest side, its largest angle would be obtuse. So just make sure when you're using this rule, C is always the longest side of the triangle. All right, let's now look at a formula allowing us to generate Pythagorean triples. So it turns out that m squared minus n squared 2mn and m squared plus n squared, they will always form a Pythagorean triad. If you do the algebra, you'll find this squared plus this squared equals this squared. So m squared plus n squared is always the largest member. So here, this will allow us to generate Pythagorean triads or Pythagorean triples. So let's find one that contains the number 41. So if 41 is a member, we're going to write 41 in this form, or this form. Now, because we need m and n to be integers, because Pythagorean triples need to be integers, 41 won't be this member because 2mn is always going to be even. So let's see if we can find values for m and n such that this is 41 or this is 41. So if we have m squared minus n squared equals 41, we need to find two square numbers that differ by 41. And you can always do that for our numbers by just about halving them. You see, 41 will always be the difference between 21 squared and 20 squared. The reason is 21 and 20 equal 41. So if you wanted to find Pythagorean triple with number 57, for example, you could do 29 squared minus 28 squared. You're looking for two consecutive integers that add up to this when you're using m squared minus n squared. 441 minus 400 is 41. So what we can do is set m for 21 and n for 20. So if m is 21 and n is 20, 2mn will be 2 times 21 times 20. So it will be 840, and m squared plus n squared will be 21 squared plus 20 squared. 441 plus 400, which is 841. So that is our first Pythagorean triple containing 41. 41, 840, and 841. Another way we could make a Pythagorean triad containing 41 is to make m squared plus n squared 41. In this triad, 41 would be the largest member, the largest of the three numbers. So now what we need to do is find two square numbers that add to 41. We can do that with trial and error because there really aren't that many square numbers below 41. So we can see that 5 squared, which is 25, plus 4 squared equals 41. 25 plus 16 equals 41. So we can come up with a Pythagorean triple by setting m5 and n4. If we do that, 2mn is 2 times 5 times 4, which is 40. And then m squared minus n squared, that will be 5 squared minus 4 squared, 25 minus 16, which is 9. So another Pythagorean triple containing 41 is 9, 40, and 41. Both of these are Pythagorean triples. So both of these are actually called primitive Pythagorean triples because there are no common factors amongst the three members. It turns out if you have a Pythagorean triple, you can get another one by just multiplying each number by the same integer. So if we double each of these side lengths, say 18, 80, and 82, we actually have another Pythagorean triple. So again, the significance is related to triangles. If you had a triangle with these side lengths, or these side lengths, or these side lengths, it would definitely be right angled. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.